little bit more challenging. See, we got to develop a robust data set. Our sensors out there don't always communicate back. We've got communications issues that happen periodically. We have power failures, construction projects, and other things that can tend to cause data to not be collected. When you go onto the PEMS website, you'll see information on there that says points observed or percent observed. And sometimes it says 0. And that means there was no actual reporting of data back from the sensors to our office. But there's a number there. You say, why is there a number there? Because the PEMS program takes the data, the raw data that's collected, and it attempts to make a guess at what that number is. But it doesn't necessarily represent an actual value that's out there. So whenever we look at data from PEMS, it's got to be, we got to pull it out. We need to review the data. We need to pull data that makes sense. We like to have data that's been observed at least 90% of the time or more, so that at least 9 times out of 10, every time I call up that sensor and says, what's your count here, I get an answer back. If you get less than that, then there starts to be some doubt as to what those actual numbers are. If we get large data sets from here and it's accurate, and that's one of the things that I really do like about that. John's talking about, you know, at the county line, he said comparing that 4590 number to what the actual numbers were from the PEMS data at the county line. Yeah, there's a difference because the county line, the sensors there, when they're counting, it catches pretty much all of the vehicles that go across that location. If we get enough of those days that we can aggregate together so that we can look at all of the data across Tuesdays, Wednesdays, Thursdays for multiple weeks, so we can try and find out what is that typical day. John did a good job with those graphs of showing, you know, over several weeks' time, what does it look like on a Tuesday, a Wednesday, and a Thursday. You get those averages, you get those values put together. And once we get a large enough sample size, you can start to look at it statistically and say, what makes sense here? Does this number make sense? Does it have value? If you have too small a data set, the number can fluctuate all over the place, and you don't really know what that number represents. And that's some of the trouble when you start getting into these low, excuse me, some of the low percent observed and just a few days where you actually are getting data. It's one of the reasons we're looking at the 2015 data. The sensors actually have not been collecting data out there in the recent, the last year, since the spring of 2015, I think it was. We have not really had good data coming back from those. We do, however, have a project that's in design or that's coming out to construction. We're going to be fixing those, so in the future we're going to get better data from that. But those are some of the things that on PEMS. With PEMS, one more thing that I do want to mention is that using the PEMS data, we can also develop better directional split numbers. When you get our census numbers from our census book, it's an aggregate number. It's eastbound, it's westbound, it's all of the hours put together. And so you have to come up with factors for how much is eastbound, how much is westbound, and how much is, what factor do you have to apply to get to a peak hour. And if you use the PEMS data, you can help zero in some of those numbers and get some good accurate figures, and you can even use that to apply to the census data and come up with some better figures as well. Next one is a few things that we've done. Caltrans has participated with the county on a number of items here. We've reviewed the TDM, their traffic demand model, and we've accepted what they've put together on there. It does provide good results. We're currently using it for study up in the Camino area and using that to analyze the results from that project. We've had extensive amount of review on the assumptions for the existing and the future level of service that's gone into the model, as well as just various discussions that we've had on this. The volume data that was used for the Highway 50 existing conditions has come from Caltrans for the major CIP and TIMP update. This latest number, the 3,900, we agreed on that one and have come up with that input. We provided a letter to El Dorado County back in July that relates to the major SIM and TIM fee updates that we do agree with the traffic analysis methodology that the county has done and the results that have come out of that. I also want to note that That's not the end of it for Caltrans' perspective. We get involved in the planning end of it, but when the county comes in with more detailed projects, when they have their, an update on their SIP, any SIP projects and that kind of thing, those are going to get more detailed analysis, more detailed review, and Caltrans is going to be involved with that. We'll have staff that will be reviewing those analysis, those traffic models, and those traffic analysis at that time. That's it for me.
Good evening. My name is Katie Jackson, and I'm a transportation planner with the county's Long Range Planning Division. And I'll just go over the last set of slides here. I'm going to talk about some of the common questions that we get about traffic and level of service. One of the most common is, why doesn't the public perception match with the technical calculations? And there can be a few different reasons for this. One is that people do tend to remember the worst days. When you're late for an appointment or you're frustrated or angry at traffic levels, that tends to stick in your mind more than when it's free flow or smooth sailing down to Sacramento. And another reason is that traffic volumes and speed tend to fluctuate a lot. And that can be based on anything from traffic accidents, weather, school schedules, seasonal attractions, heavy vehicles, and even vehicle platooning can affect that. Now, a vehicle platoon is a large group of cars that are traveling down the roadway together. And if you're in the middle of that platoon, the density around you might feel heavy. But there might be a stretch of roadway behind you where you have much lower density. And so it's important to remember that when we talk about the peak hour level of service, we're averaging that across the entire peak hour. It's not just for a single point in time. Also, research from the American Society of Civil Engineers shows that it tends to be difficult for the general public to distinguish between different level service grades. And that perception about level of service tends to vary greatly from person to person. And that's why that's why our general plan calls for all of our technical calculations to be based on the Highway Capacity Manual. That gives us, it's a nationally recognized standard that's based on observed data, and it gives us an objective result. So another common question that we get is, why have traffic levels increased in the last few years? And there's a couple of reasons for this, and I'll go over two of the primary ones, and they're both related to the economic recovery. This slide here shows the county's unemployment rate through that time. In 2010, we had an unemployment rate of about 12%. By 2015, that number was down to just 6%. So there's more traffic, there's more commuters on Highway 50 during the peak hours getting to their jobs. Another reason for the increase is that we've also had an increase in residential building permits during that same time. So most significantly, those increases happened in the Dorado Hills community region and also in the rural region. Those are the top two lines that you see on this graph. So what does this mean for future traffic levels? Well, we can expect that the residential building permits will continue to increase, and those new houses will continue to add traffic to our county roadways. However, we don't expect that the unemployment rate will drop significantly below today's levels. And so we won't see the same rate of traffic growth during the next 5 years as we did during the last 5 years. Another question that we get a lot is, what is the county doing to prevent level service at the county line? Recently, we constructed HOV lanes on Highway 50, as well as improvements to the Dorado Hills Boulevard interchange. In 2016, this year, we opened the Silva Valley Parkway interchange and constructed Carson Crossing Drive. We have a number of future projects. We will continue to work with Caltrans to adjust the ramp metering rates along US 50. And I know ramp meters can be a little inconvenient, but they really do help to maintain level service and speed on our highways. We also have a number of CIP projects that are planned for the future. That includes the Saratoga Way extension. Initially, that'll be built as a 2-lane roadway and then widened to a 4-lane roadway. We have the White Rock Road widening project across the county line. We'll be adding auxiliary lanes to US 50. And then we have the Green Valley Road widening project. Now, that's primarily a City of Folsom project, but we will be working with them closely on that one. And the county is also working to prevent unacceptable level of service and improve our roadways throughout the unincorporated western slope. And we have a number of different programs that help us do that. We have our traffic count program where we count all of our major roadways every single year. In 2015, we counted 92 different roadways at 223 different locations throughout the county. We have our intersection needs prioritization process in which county staff monitors the level of service and the volumes at individual intersections throughout the county. And then we prioritize improvements based on a number of factors, including level of service, signal warrants, collision history, bike and pedestrian activity, and also Board of Supervisors direction. We have our travel demand model, which we update regularly to make sure our forecasts are as accurate as possible. We have our capital improvement program and our traffic impact mitigation fee program. Those go through minor updates every year and major updates approximately every 5 years. And through that process, we adjust our growth rates, our construction costs, and our project schedules to make sure that we're timing projects appropriately. Right now, the county's transportation division has 24 projects in our CIP that are under construction or scheduled to begin construction in this fiscal year. And we also have 31 projects that are in the planning, design, or right-of-way phase during this fiscal year. So in addition to monitoring our traffic operations, we have a number of other programs. We monitor pavement condition through our pavement management program. We monitor traffic safety through our annual accident location survey. We have our traffic advisory committee, which is dedicated to the placement of traffic control devices. That could be a stop sign, a speed limit, a crosswalk, things of that nature. And we also have our maintenance team, which responds to hundreds of requests every single year throughout the county. So this is a very comprehensive set of programs. I'll get to your question in just a minute. This is the last slide.
Yeah, well, I wanted, while you're on that slide, I want to ask a question.
Okay. So I just wanted to finish by saying we have a very comprehensive set of programs that addresses both the existing and the future roadway conditions. Do you want to ask?
So you mentioned 55 projects there. Are those funded? Are those all fully funded?
Yes. That's in this year's CIP book.
Those all have funding to move forward with them. And then,
currently.
And are those actually going to improve LOSF? Because you mentioned a lot of things that are more accounting for, studying those issues, but are any of these projects actually going to prevent LOSF?
So we have the list of projects in our CIP book, which is sitting right there on this counter. And I don't want to go through them one by one, but we'd be happy to go through that list with you of the current projects and address your question there. So next steps, we have a Board of Supervisors special meeting planned for Friday, October 28th at 1 p.m. At that meeting, we'll be going over the same information, but also including a summary of public comments that we received tonight, questions, and also answers to those questions. And we'll take questions in just a minute, but if you have any additional questions that you think of after tonight or that don't get answered tonight, you can submit those via email, fax, or in person to Claudia Wade here. And if you get them in by Friday, this Friday, October 14th, we'll include them in the summary for the Board of Supervisors meeting on the 28th.
And there are comment cards back here to fill out if you want. If you want to just write it down and hand it to us, that's fine. If you don't want to ask us, you can always write it down and give it to us, or you can email them. And all that information is on the comment cards.
And we will be posting this PowerPoint presentation on the county website as well.
So with that, we'll take anybody's questions.
John?
So this afternoon I went to the PEM's site for Caltrans and I downloaded the data for August and September of this year. I threw out all the sensors that had less than 100%. So you should be all good sensor readings. And for those 2 months, I have 21 days that have come to level of service F on Highway 50 at the county line. So this actually represents what we see on Highway 50. how do you explain those differences? You know, this is the Caltrans data. It's been filtered. This is Tuesday through Thursday, using the good sensor data from PEMS. You know, we get speeds down frequently 20 miles an hour, 7 miles an hour, 12 miles an hour, and these persist typically for 1 to 2 hours during the day. And so it seems like we still have this problem where we're not really seeing what, you know, the theoretical calculations that are being provided don't really match reality, what we're actually seeing. The second part of this question is, Caltrans has issued 2 letters now that specify that segment is at level of service F. Has Caltrans changed their mind on that?
I mean, we have not changed our, I mean, from the standpoint of what the analysis is that's being done here and the traffic volumes that we've looked at in 2015, it is a level of service E based on that information. I'd be curious to look at the data that you have specifically there, but the PEMS data is also looking at, you know, specific spot pieces along there.
Exactly. So I can show you the exact spot that we're looking at. But also there have been two letters issued to the county from Caltrans, Eric Frederickson and one other person at 2 different dates specifying that segment is at level of service.
I'm not familiar enough with those to respond to that.
I believe that those letters is part of the TGPA, I think, and I think that's where we addressed this later, is that we later determined, that was the slide that talked about the volume of 4,4590, that volume from the TCRC SMP, and it was later discovered through further coordination with Caltrans that was based on their document. It had a higher volume count, but it wasn't appropriate for our planning purposes. As we went through the count data information and worked closely with Caltrans, we found that that was not an appropriate volume for county's purposes of collecting fees.
Okay, good. Well, good. Push that up.
Yes. Oh, I'm sorry, Rendell.
Yes. Is there a metric for safety that would be comparable to the motor vehicle level of service that, as I understand it, is a measure of capacity?
I'm sure.
Well,
The question is, we do measure safety on the highways.
but the motor vehicle level of service is not the safety measure.
No.
Okay.
No, the safety measure is based on the number of collisions out there in terms of collisions per 1 million vehicle miles traveled.
So is there a safety measure that's attached to roads or segments of roads?
Yes, we can calculate that. I don't have those numbers with me tonight, but
Okay.
we can calculate that.
Thank you.
Bill first and then Noah.
And one of the things that Bill Center, Major White Committee, one of the things that the graphs pretty clearly showed was that as speed dropped, volume dropped. And so one of the concerns that we've had is that the county continues to insist on using primarily, if not exclusively, the volume data. And as I said before the board a couple of weeks ago, using the volume data, taking it, albeit to an extreme, if speed is 0, volume is 0, and therefore level of service is A, which makes no sense. And so when the PEMS data is showing that the speed is dropping on a consistent basis, and the county is using, as far as we can tell from their communication with us, pretty much exclusively volume as a determination of whether there is a level of service F threshold, i.e. 4,000 vehicle trips per hour. So that's a concern, that there is a robust data set, but it does have holes in it. But one of the things that we haven't seen on any of the data that you presented was traffic data from the Tuesday to Thursday period in the fall in recent years. And consistently in your presentation, you started to refer to average, typical, non-accident caused as a measurement or as a criteria for measuring level of service F. And that, to my knowledge, does not appear in the general plan as the criteria for level of service F. It is an average. We all know accidents occur more frequently when traffic is intense, when density increases. So one of the things that happens is that you get this kind of perverse reaction where there is less volume in lower speeds, and therefore what you're ignoring is that the HCM, which you said is a nationally recognized standard based on observed data, but what you didn't say is that it says you need to use not just volume, but speed and density in determining level of service. You've also said that you've made 2 or 3 basic assumptions over the next 5 years. Number one, that you won't see as much traffic increase in the next 5 years as in the last 5 years, because you think that the unemployment rate isn't going down. It was the primary reason. You said that expanding parallel capacity and expanding and adding auxiliary lanes to Highway 50 is going to occur. The implication was that was going to occur in the next 5 years. I do not believe that that is slated for completion in the next 5 years on the CIP. And I do not believe that it is fully funded. I may be mistaken, but I haven't seen any data that the design has been approved by Caltrans. So I guess my question is that at what point or with what data will the county acknowledge that Highway 50 has reached level of service F, and can they say that up front so people can be clear about it? In the community region of El Dorado Hills, and as importantly, at what point and with what data, particularly on a modeling point, will Highway 50 reach level of service E in the rural region between Cambridge and Bass Lake? Because that is the general plan standard. So you can put that as part of, if somebody wants to take a fly at an answer, that's great, but if not, I'd just like it to be part of the records.
I'll take a crack at, there's a number of points that are big questions within your statement there. The graphs we were showing were volume and speed. The highway capacity manual, really its measure for level of service is density. It's the number of vehicles per mile that you observe or occurs on a roadway segment. And for lower densities or even densities that get fairly high, speed doesn't drop very quickly. It stays up at a pretty high rate until you start getting close to the capacity of a freeway. When you start getting close to it, then it starts to drop off slowly until you get fairly close to capacity, when it drops off quite quickly, when you get up close to level service F. And so you can get lower volumes when you have lower speeds, because all of a sudden you are getting too dense in your capacity. The amount of vehicles that can actually travel to a point starts to drop off because you're getting right up at near its capacity. That's a technical kind of explanation of things where, traffic engineers kind of live and breathe. So the real measure, we're showing you volume and speed because that's key measures that we can measure and we can relate to. But really, when you make the calculation of level service, whether Caltrans is doing it by their methods through PAMS data. Pardon?
Use the same HCM.
Yeah, but I mean, they can use some of the real-time data they have from PAMS and so forth to estimate density. And so they're measuring level service that way. And the same thing when you apply it in a high capacity manual, you're measuring density on a freeway. So it's a harder concept for us to get across to you, measuring density, but that's really what the level service is based upon. And speed does matter, yes. Speed is definitely a component of that. It's not just about volumes.
Just to elaborate too, there are two methods I think we've talked about in the past. There's a planning and operations analysis kind of thing. And this highway capacity manual does include what's called service flows. So there are flows even in the instance of basic freeway segments, which is the chapter you're referring to, which includes estimates that are basically volume-based. And those are for planning purposes, and they're very appropriate for using with a model. Now, what you're talking about when you talk about more detailed operations analysis is what he just covered, which results in a density measurement, which is a much more detailed operations analysis.
And I would add, in your example where you have very low volume but also very low speed, that means traffic is pretty much standing still on the freeway. That would give you a very high density, and it would report level service F, even though it's a very low volume, even if the volume is 100, because hardly anybody's getting through. In that situation, the speed would also be 5 miles an hour, and when we run the calculation, you would get level service F. So it's not all about volume. You notice that between 2020 and 2015, we showed the level service getting worse, even though the speed got better. Speed went up from 50 to 55 miles an hour, but we're actually showing level service E because it is more dense out there now than it was 5 years ago.
With all respect, that also includes the HOV lanes, and so you have a higher average speed because you're averaging the HOV lanes into that set of data, and the density is being measured on the capacity lanes. And we're not looking at the HOV lanes as being the measurement of whether we have level of service F or not. And also, with all respect, it would appear to me as a layperson that the capacity that is used for saying in your various graphs, I believe it was 4,000 vehicles per hour. It might have been 5 for the level of service F. That capacity appears to be higher than we would, I'll back up. When that capacity